The new stuff added today, because we're still going to worry about domain and range, but we're only going to worry about domain. When we go algebraically, the graphs go away. Finding the range is very hard, if not almost impossible. In calculus, when we analyze it, it's the last thing we do, and we've actually made a sketch of the graph to do it. And so the range, you might be able to, with some of our basic functions, come up with an idea. But for what we're going to do, we're going to just algebraically look at these and try and decide which numbers can I put in this function or put in this machine and not have it blow up. Now, there are two things I can do to your machine to make it blow up in math. One is I can put in something that has division by zero. Okay. What was that? That was kind of weird. So, you divide by zero. Division by zero is bad. Okay, so that's one way to break the machine, is to divide by zero. And we want to find out, one, who does that and not use them. Okay. And the other bad thing we can do in the real number system is we cannot take the square root of negative numbers. These, division by zero, usually are just with fractions. So if you don't see any fractions in your original equation, everything's going to work. Okay? And I'll show you a couple examples like that. These obviously are just with square roots. If you don't see any square roots, you don't have to worry about these. Sometimes they're in combination with each other, but I think we save that for later on. Okay. So what I'm going to do is go through a couple examples, and we'll kind of work through some of the homework, and then we'll be done for the day. So up here I've got 5 different functions, and we want to identify just the domain of that function. To identify the domain, we're looking for two things. One, is it a fraction? For this one, yes. Is there a number that I could use that would make the bottom 0? Any number I could pick that would make the bottom 0? -3. The way you can kind of mess with it is, here's on the bottom. You do not want that to be equal to 0. You don't want the bottom to be equal to 0. So we can play around. Usually that's an equal sign, but algebra will work. And you'll see me write that. X cannot equal -3. That's the domain. You don't want to use it. Everything else works. Okay. There aren't any square roots, so I don't have to worry about that part. So we're looking for the bottoms, see if they blow up. Second one, x squared plus 5x minus 6. Any fractions? Nope. Any square roots? Nope. So everything works. So here's how I'm going to write the domain. That means all real numbers. Everything works. The domain has no restrictions on it. I'm going to write that fancy scripted R. Third example. X squared minus 5x plus 6 divided by x squared minus 4x plus 4. Oh boy. It's got fractions, doesn't it? No square roots. So, my first task is to find out who might make the bottom 0, right? Well, what do we usually do with stuff that looks like this? By doing the factoring thing. Don't cancel anything. You can't do that. You got to factor. So, I'm going to make the front. What do I make 4? 4 and 1, but that's not going to add up to -4, is it? 2 and 2 must work. 2 and 2, that one work? +4, and then they add up to -4, right? Yeah. I think I'm good. So, which number blows it up? 2. You don't want to use 2. For the domain, x cannot equal 2. Are we worried about the top? Eventually, but right now, that's all I want you to worry about, is the bottom. Okay. The top will come into play in a little while when we start to remove things, but I just want you to worry about the domain for right now. So if it's not nice like that first one, use your factoring skills to come up with what you need. All right, these last two have the square roots. So if you look at the first one, no fractions, so I don't have to worry about that, but it does have a square root. Can't take the square root of negative numbers, so it's as basic as this. Whatever's inside the square root has to be positive, right? Has to be greater than or equal to 0. That's what's inside. So in this case, x has got to be greater than or equal to 0. There's my domain. That's the basic one. It does get a little trickier on this one. 2x minus 5. That's inside the square root. Whatever is inside the square root has to be greater than or equal to 0. Okay. Whatever is inside the square root has to be greater than or equal to 0. Okay. I'm going to go put that over here in the blue notes. I don't think I did. Inside the square root has to be greater than or equal to 0. That doesn't mean x is always greater than or equal to 0. What you're going to have to do is solve an inequality. 2x greater than or equal to 5. So x is greater than or equal to 5 halves. So there's your domain. Okay. Now, does anybody remember the one thing you got to watch out for with inequalities when you're trying to solve them? If I divide by a negative, I'm going to have to flip the sign. So let's just say, example-wise here, I had the square root of 7 minus 3x. I had that. And I wanted to find the domain. If I want to find the domain, it's got to be greater than or equal to 0. So 7 minus 3x has got to be greater than or equal to 0. I like to always keep the letters on the left and the numbers on the right. And so now I'm going to divide by -3. So I'm going to have to switch that direction and make that positive 7/3. So there's your domain right there. Okay. Boom. That's the new stuff. So on page 10, there's 39 through 46, but skip numbers 42 and 44. 42 and 44 don't do. They're a little more challenging. So you run into those. You got about 10 minutes. You probably can get done with it before we go.